I'm David Williams, and I'm a chemistry professor at Auckland University. My professional career has been around basically how to measure stuff, kind of sensors and things like that, chemical measurements. So there's a group of us at Auckland. I work a lot with Yadranka Travis-Sadich, so she's another professor in Auckland, and you know, we work on measuring things. And Marion approached Yadranka first and said, you know, oh, there's this problem about trying to measure the greabies in the soil that are going to go and infect the kauri trees. You know, how can we detect them? Yadranka asked me, and we, you know, have a bit of a brainstorm and nut it out, and yeah. And said, well, maybe we could do it, and this might be a way to do it. And so, you know, write a proposal. And they said, looks like it might work. Well, it's got a long name.
What's the long name?
Oh, I can't. I think it's called a microcytometer. I think that's something like that. Or a microfluidic flow cytometer. So what it is, right? So I haven't got one, so you have to try to imagine it, a little tiny block of plastic. And in the block of plastic is a channel, and the channel is smaller in dimension than a human hair. So it has to be just a bit bigger than these little beasties that you're trying to measure. The idea is to persuade the beasties to travel up the channel, to swim up the channel. And if they swim up the channel, they provide a little bit of a blockage. They don't block the channel, but they're kind of a little bit of an obstruction. And if you have a pair of electrodes in the channel, and the beastie goes past the electrodes, you can look at the way electric current flows between the electrodes, and it detects the little blockage. So you get a pulse as the beastie flows through the gap between the electrodes. So the channel is smaller than the dimensions of a human hair, and so are the electrodes, and so is the gap between them, because you're measuring something small. The first level is, are you smoking dope, right? Is this just really stupid? Can you actually measure something? So Pikai made these things, and sure enough, you can see little polystyrene balls going down. But polystyrene balls are not beasties, right? They're hard, and beasties are soft. And so Shimini worked out how to grow some beasties, which is non-trivial. And then Pikai showed that actually you could see them. So that's kind of cool. So that's the stage we're at, basically. Yeah, got a signal. Amazing. Well, first you've got to measure something, so you've got to get a signal, right? So you've got to figure out the electronics required to get a signal. You know, how big a voltage have you got to apply, and what frequency should it be at? You know, it's an alternating one, so it's doing this, and so how fast should it go? And then how are you going to detect that? So the next part of it, the project was actually the detector. Can you detect this thing? And Logan, we were sort of having discussion, and we found this thing that you could buy, an actual chip that actually was just right. And so they got hold of it, and they were able to put it together, and it works. Now you've got the most difficult part, which is you can detect these things if they go past the electrodes. So how are they going to get there? So now we have to do experiments with these little beasties, actually with a version of the beastie that isn't infectious to trees. So my understanding of this is that there's the chemicals that are coming out from the roots of the kauri trees. And these things detect those chemicals and swim towards them, and then get into the root and go up the root, right? Okay, so it turns out that carrot juice apparently works to attract these things. So now we can now sort of start to explore what happens to these things when they've got when they detect some carrot juice, right? How fast do they swim, and how far do they swim? And can you get the carrot juice into this tiny channel in such a way that it seeps out the end just enough to attract the beasties? And when the beasties come along, will they go into the tube? Will they actually go into your channel, or will they just stick at the outside? So do we have to make a shape at the beginning of it? And how fast will they swim? Will they stop swimming? Will they stick to the walls? And all this kind of stuff. And when we can do all this observational thing, right, about the way in which these creatures are behaving, then we'll know how we shape the inlet to the channel, where we put the carrot juice, how we get the carrot juice into the channel and just kind of just seeping out the end. What's the concentration of carrot juice, right? You don't know. And where do we put the electrodes? So there's a tree, somewhere around there are beasts. You want to know if the beasts are getting towards the tree, where are you going to put the detectors? Because if the beasts go, you know, the detector's here and the beast's over there somewhere, the detector's useless, right? So there's a whole other thing about where do you put these things and how many of them do you need. The sense is only the very first part of all of this kind of thing. You've got to have something which is monitoring the signal automatically, looking for pulses. And it has to say what's a real pulse and what's a fake one. To me, it was like if I was asked if I'd like to, you know, contribute in this, and you go, oh, of course, right? If you can find a way to help stop this stuff. Well, you're providing new ways of seeing, I think. Ways of seeing things that you can't see with your eyes. Of kind of, you know, a lot of other stuff that I do is do with measuring air quality. Right, measuring gases in the air. We can't see it, you can't smell it, you can't taste it. And the company I work, they have a slogan called making the invisible visible. And a lot of what I do is like that. It's measurement of you know, measurement like detecting these little beasties or, you know, chemicals one sort or another. You have to extend your senses. And it makes this thing visible. And when you've done that, now you can integrate it into all sorts of things, right? It becomes now part of your knowledge of the whole system and what are you going to do about it.
Ko Waio, ko Kirireihana tōku ingoa, he uri no Ngā puhi me te rarawa e tētaha tōku pāpā, he uri no te whakatohea ngai tūhoi i tētaha tōku māma. Dave I met because he used to work for Ngāti Rangi, and the basis of the cultural framework that we'd done the work from comes from the Ngāti Rangi work I did. So with Ngāti Rangi we did a forest health or Ngāhere Ora framework to look at what the health of the forest looks like from their perspective. So Dave knew I'd done that work and asked me if I'd be interested in doing a similar kind of thing in this research, which is now being coined cultural monitoring by quite a few people. So
Is that what you call it?
I would say a mātauranga monitoring. It's framing the environment from their own perspective and understanding it from their own perspective, capturing information from their own perspective, and then being able to communicate that back out into reports, board meetings. But ultimately it's information to go into decision-making forum where they can start making decisions with mātauranga, Māori knowledge, as well as other knowledge systems as well. So at least we're participating in that co-management space from our own point of view. What I've observed from doing this kind of monitoring, that's what iwi are really wanting, is their own data so they can present it in their own way and to contribute to decision making around their own resources. We start with noho taio or marae noho, where we extract out things that are the values of hapu and iwi, whakatauki, because each iwi obviously has their own mita as well, so their own dialects, their own worldviews. So we try and capture that. Then from that, we'll turn that into some kind of metric matrix, where we can use it to measure those intangible and tangible concepts like whanaungatanga, manaakitanga, Māori, from their own point of view. Then we turn that into a field sheet. We test it in the field with their kaimahi on the ground so their kaimahi can feedback. So it's a reiterative process. It'll start off with their elders, it'll go through to their people on the ground, but we take it back to the elders, the kaumātua or the senior specialists that they identify in their iwi or hapu, and just to get them to okay it, to mandate it, so that we know that we've done the right process to ensure that this is a true reflection of the iwi or hapu we're working with. We've moved into this post-treaty settlements, a sort of phase where Māori now have a say in our natural environment and our resources, and so they want to, but they want to present their worldview on it, their perspective on it, and their data on it as well. We haven't been at the table, the decision-making table, for a very long time, and I would say that this kind of, pushing towards getting this has been, got traction in the 80s, probably started in the 50s and 60s with our tupuna, wanting to not just get their land back, but also having say on the land that they didn't get back, like national park land. Or the mataitai they call it, or the marine reserve land that they've got now and the different names. They had those coming through legislation, but enacting that on the ground and affecting it in the decision-making co-development spaces, there hasn't been a lot of traction we've gotten with that. So I think it's coming to a point now where we're starting to get traction. We're starting to understand the research system and how to collect knowledge in that particular way so we can do it our own way, but from our own worldview. Because unless we're making that those decisions informed from our own worldview, it's not representing our worldview either. How we've broken the framework down, or how Ngāti Rangi broke it down, they broke it down into what they call domains or attributes, which are areas that we wanted to focus on to look at the health. So for Ngāti Rangi, it was rongoa, wai, tangata, rākau, and the ngāhere in general. So we've gone with the same things. We've also added in for this particular one is awa. I'm looking at the awa itself. So there was two sort of sections on water in the forest. When we did the Ngāti Rangi framework, they concentrated on what the wai was in the forest. That was measured by a metric of mauri, how flourishing the mauri was in the forest based on the water content. So when you're in the ngāhere, there's a smell. It's usually the decomposition smell of the earth. So when it's really moist, they were measuring that as a real healthy smell in the forest. And then when it's dry, it's not as healthy. When we were in the bush talking about that yesterday, because there's been droughting up here, it was a real dry smell, even though it's this late in the year and the forest's up there. So it's understanding those things that happen in the forest, the processes that happen in the forest that make the forest well and healthy, and water being a big part of that. In this particular in this research stream, we've used also looking at the awa, or the lakes that are associated with the forest that we're working into, and measuring the health of that through the presence of taonga species in those awa, the clarity of water, how clean it is, how not clean it is, depending on where the source is coming from too. So we've added that other dimension to this particular one. What we still have to develop is cultural indicators or indices around the Kauri dieback and the myrtle rust. I know Ngāti Rehe has done a bit of work in that space. We looked at the Kauri health indice that Tui Shortland and Julia Cheetham have done. A lot of what we've got into ours marries up with that one. So there's some specifics we're still wanting to find out. So having kōrero with people like Tohe Ashby would be really valuable to refining what that might look like for these kaitiaki and kaimahi. That connection to whenua, I think, is just so important for so many reasons, physically, mentally, spiritually. We are much happier beings when we're connected to the whenua. And whenua, moana, awa, the taiao, whatever that looks like for anybody, humans are much happier in that way. And I'm a conduit of what is needed at that time. A friend of mine, Hema Wihong, she always comments that we're just the baton holders, the rākau holders of this moment, because our knowledge is intergenerational. And our work is intergenerational too. It started with our nannies and aunties and doing all the mahi they saw that was important of that time. And we're just the conduit of this time as far as I'm concerned, yeah. you know, some people are special, you know, and have those special abilities and hold those special mātaurangas, like I mentioned before, Ririata or Tohe or Pā McGowan. But mātauranga is not supposed to be held and kept, it's supposed to be shared, so it has that ebb and flow like a river, so it moves through the generations and it picks up, you know, the gold bits on the way, the nutrients on the way when you're in a river, until it deposits it at another place. So I guess I see mātauranga like that, being in the environment, it reflects, our knowledge reflects the environment of the time.